and let's talk about selecting a sample. The first thing to talk about is the definitions. These sometimes graduate students use these interchangeably, but they are not interchangeable. These are very different. A sample is a group of individuals, items, or events that represent the characteristic of a larger sample from which that sample is drawn. So the small group is always the sample, the large group is the population. So for example, if you were looking at Fresno State students, right? Fresno State students could be a population, and a sample among those Fresno State students could be student athletes. So student athletes are a sample of a larger group. Now, at the same time, when they're a sample, it all depends on who you're comparing. You can also say student athletes are the population, where perhaps football players are the sample among that population. You can go in the reverse as well. You could say Fresno State students are a sample of California State University students, which are 23 universities. So the comparison purpose is important to be able to identify which is the sample in the population. And this question here is a question that we may ask in some way, shape, or form in your quiz. Okay. So in quantitative research, sampling, and in qualitative research, there are some nuanced differences. So when we're talking about first, let's talk about quantitative research. So a sample is well selected. It's representative of a generalizable population, something that you can generalize to. This term is important, generalizable, because on the qualitative side, we don't use the word generalizability in the same way. Okay, so the steps in sampling and quantitative: first, you define a sample, something that you can generalize to. As I said, if we're going to talk about student athletes, let's say football players are the population of student athletes, and maybe the sample, or say the population is football players. That's going to be generalizable to all student athletes. Okay, and then you select a sample here. Number two, either going to have random selection or non-random selection. So if I want to know what is the student athlete experience of football players at Fresno State, I just want to randomly, I don't want to just sample, I don't want to just talk to, survey football players or just the offensive line. I want to do random. I want to pick, go put them in alphabetical order by their last name, and I want to sample each third student to give me a sample, or every fifth student, and that's randomized sample. Every student in that population has the same possibility of being selected. A non-random sample is different. It may be, hey, I'm just going to survey whoever is out there today, in the weight room, maybe whoever's in the weight room today. That's who I'm going to interview today about the experience at Fresno State. Well, that may not be representative, because if they're in the weight room means that they're maybe putting extra time, maybe are extra dedicated, and so therefore they might all have a really good experience at Fresno State. Who knows, right? It just would not be a random sample. And then number three, also addressing sample error and bias, real and potential, which we'll talk about a little bit later, but there's always that possibility of errors and bias within sampling. Okay, so in quantitative, again, we have the random samples, right? Random, remember, if we think back to chapter 1, random assignment in experimental studies are the highest degree of the most sound studies, the studies that are going to give you the greatest degree of certainty. So random sample equals less chance of bias. Okay, so we have a simple random sample. Everyone has an equal dependent opportunity of being selected. As I said, I'm going to put all the football players on the list, and I'm going to select every third one, and then that is going to give me a simple sort of random sample. Then you have a stratified random sample. Okay, say I want to split the offensive line and the defensive line, and then I want to do a random sample based on first the offensive line on one end and the defensive line on the other. So we're in the simple random sample. It could have been that when I selected every three, they could have all ended up being, or 70-80% of them could have been offensive line. We're in a stratified random sample. If I'm selecting, say, 20 students, 20 football players, they're each going to get the same opportunity of being selected on the offensive side and the defensive side. because I've basically stratified the sample into two, offensive and defensive, okay? And then I'm going to select 10 from here and 10 from here. Then you have the cluster sample. You have just an intact group. You're going to just random sample, those. So I'm going to go out into the field, and whoever's there today, hopefully everybody's there, but maybe a couple of football players are injured. So they're not going to even get an opportunity to be selected. They're at home resting. The ones that are out there, that's the cluster. That's who I'm looking for. That's who I'm going to randomly select from. And then you have a systematic sample that you want to get up to a certain amount. So I want to say I want to get 50 student athletes, and I'm gonna select them all. They're all going to be at an event, and I'm gonna or put them on the list and systematically just keep selecting until I reach my determined population of 50 or 100 or whatever my number is. So that's systematic. Okay. Non-random samples, okay? There's a little bit more chance of bias in these, but again, remember, these are very common in educational settings for many reasons, okay? You have the convenient sample, right, where I'm just gonna go to school today, whoever's there, that's who I'm gonna sample today. And if I'm, talking and I want to ask them about the weather and how they like the weather, and they may all like the weather if it's a hot day and they went to school. The kids who don't like the weather maybe stayed home. And so it's convenience, because I don't wait for a good weather day to sample them, or I don't try to control for the weather. I just basically go in there and say, this is who I'm going to be sampling from. And then you have a purposeful sample. You're specifically, trying to select a specific population for whatever reason. So if I want to find out what does it mean to be, a star athlete, a star athlete at Fresno State, I may just, select maybe like the quarterback. I may select maybe the running back. I may select certain key, football players that maybe, are getting, a lot of coverage. I may go to the basketball team, select a couple there. I may go to the water polo team. So I'm going to be very purposeful in my selection and really select maybe like the team captains or maybe like the star athletes. And that's a very purposeful sample. Then you have quota sampling, which means I just want, again, 20 students. I'm going to continue to try to do these interviews or these surveys until I get, up to my quota sample. This is very common when you have a budget and you can only collect so much data. And I do this quite a bit because I'm usually, in some of the grants that I get, there's a budget. And so therefore, I can only collect a certain amount of data. And then you have sampling error. This is the chance that your sample was not going to be representative of the population. For whatever reason, you didn't account for a certain variable, and therefore the sample error increases. And then you have sample bias, and this is really the researcher error. So you really try to avoid the sampling bias, but as a researcher, so say for example, I'm interviewing only Latinas that say that their experience are similar to those of Latinos, okay? And so this is a very specific sample, and when I get that specific, there's that greater chance of the bias, okay? So sample size, this is the big question. How much is enough? How many do I need? So that's a very difficult question to answer, but the short answer to that is it does have to be big enough to be representative if you're doing qualitative, and generalizable if you're doing quantitative. Generally in the social sciences, we look for this 95% confidence interval, okay? In the medical sciences, we look for a 98% or 99% confidence interval. But with a 95% confidence interval, this is good enough for us to be able to say, with a great degree of certainty that, hey, we know that this is true with a 95% certainty because of the size of the sample that we obtained. Okay, and here's a website here for more for a sample size table for confidence and sample size. You can go there. All right. Qualitative is a little bit different. The definition is that a sample of a small number of individuals chosen likely because they are key informants that are going to contribute to the understanding of phenomena. So there's steps. First is you define a population, not necessarily generalizable, but the word that we use a lot is transferability. Transferable. Okay. Uh, so after that, you select a sample, usually a non-random sample. You address any sampling error and bias, and we'll talk about this a little bit later. And then we also determine the size and explain the reason for that determination. One term that we use a lot to say, hey, usually there's not a set number unless you have quota sampling. Usually there's a range. Okay, and within that range, we're going to have whatever, 5 to 10, whatever that range is, and you're trying to reach a level of data saturation. Okay, data saturation means that the themes in an interview start repeating themselves, and once they start repeating themselves, you can stop doing the interviews because you know with great certainty that you have enough data to explain the phenomenon under question. Okay. You have non-random samples, quite a bit of them on the qualitative side. Obviously, we talked about convenience, purposeful, and quota sampling already, the same as quantitative. But you also have this intensity sample. And some of these may look the same and sound the same, but they are very different, or maybe not very different, but they are different, and they are different techniques that are used in research. So this intensity sample is a sample that permits you to look very intensely at a particular phenomenon. So you get real specific. So here I'm looking at Latino 9th grade math students at, Bullard High School. Okay, homogeneous sample. Okay, a sample where the participants are very similar. Same thing here, Latino male 9th grade math students at, high school, at Bullard High School. That's a homogeneous sample. You assume that all of them are going to be very similar. If they're not, if maybe some of them are student athletes and some of them are not, then maybe you want to separate those out so that you get a real homogeneous sample that's going to provide a homogeneous experience. Okay, criterion sampling. The sample selects participants that fit a particular criteria. So I say I want Latinas, I want them to be students, I want them to be able to self-identify as Latinas, but they don't have to necessarily be born or raised in the U.S. So you have all this different criteria that you set, and all the participants that are part of your study must fit all of those levels of criteria. Snowball sampling. This is really when people are sort of hard to find. Like one example is undocumented students. We do have the Dream Center that can probably help you with that, but generally, that's not a population that is easy to find. So once you find one or two, one of the questions that we ask in interviews is there anybody else that you know that is having the similar experiences that maybe I could talk to? And generally, people that are trying to hide, or people, people or students who don't want their identity known, generally know others that have similar experience. And then you have random purposeful sampling, and this was a sample that selects more participants than those that can participate in the study, and then randomly selects from those participants, such as 100% administrators for a survey, and you randomly select 15. Okay, and then to determine sample size and explain for the reason of the determination, address maybe data saturation was the term I brought up earlier. When information, thoughts, perspectives begin to repeat themselves, you know you've reached that data saturation point. Definition of data saturation, here we go. The point at which the data collection can cease, which means stop. Okay, you can stop data collection at that point. This point is reached when information being collected by the researcher begins to repeat itself. Researcher can reasonably be confident that saturation point has been reached. Unlike quantitative, researchers who wait until the end of the survey to analyze their data, qualitative researchers always analyze data throughout the data collection process for the very specific purpose of trying to understand when they've reached that saturation point. Okay, and this is really just a sample of probably some of my work, I think, is where I pulled it from, where I use sort of multiple sampling techniques all in one. Sometimes one sampling technique works. Sometimes you need a combination. Here in this one, I use not only quota sampling, I also use snowball sampling, and I use both of those together to be able to attain my sample. And here's another example here of sampling. Here I use quota sampling, and you can sort of read this, and this is also, you can pull down the PowerPoint slides and read it to see how you write one of these sampling sections. And you'll need this actually for your final project, which